Are you interested in becoming an embedded software or firmware engineer but don't know where to start? Maybe you've seen some cool projects online like custom keyboards or DIY drones and thought, I want to build that. Well, you're in the right place. In this video, I'm breaking down 5 essential skills you need to master to kickstart your journey in embedded systems. We're talking core concepts, practical tips, and project ideas to get you hands-on right away. So, let's dive in. First up, we gotta talk about C programming. Yeah, I know, learning a programming language might seem intimidating at first, but trust me on this one, C is the backbone of embedded systems. Why? Because it's efficient, lightweight, and gives you direct control over the hardware, something you need when you're working with limited resources. Now, when it comes to C for embedded, you'll want to get a good grasp on things like pointers, memory management, and bitwise operations. These might sound a bit technical now, but they're essential for interacting with the microcontroller's memory and peripherals. The good news is, you don't need to be a coding wizard to get started. Start small. Try writing a program to blink an LED on a microcontroller. It's a classic beginner project that teaches you the basics of C programming and microcontroller interaction. Next up, we're diving into the world of microcontrollers. Think of these as tiny, self-contained computers designed for specific tasks. They're the brains behind everything from your microwave to your car's engine control unit. Now, there are a ton of microcontrollers out there, but some popular choices for beginners include the Arduino, STM32, and ESP32. Each has its own strengths and ecosystem of tools and libraries. The key here is to pick one and start experimenting. Learn how to program the microcontroller, control its input and output pins, and interface it with different sensors and actuators. A great way to get started is by building simple projects. Try controlling LEDs with different patterns, reading data from a sensor, or even controlling a small motor. Chapter 3. Electronics, speaking the hardware language. Now, you can't call yourself an embedded engineer without understanding the hardware side of things. Don't worry, you don't need to be an electrical engineering whiz, but a basic understanding of electronics goes a long way. Start by learning how basic circuits work, things like voltage, current, resistance, the fundamentals. Then, move on to reading schematics. These are like blueprints for electronic circuits, showing you how different components are connected. You'll also want to get familiar with common electronic components like resistors, capacitors, transistors, and how they're used in circuits. And the best way to solidify your knowledge? Build something! Grab a breadboard, some jumper wires, and start experimenting with simple circuits. Chapter 4. Debugging, embracing the bugs. Let's be real, in the world of embedded systems, things don't always work perfectly the first time, or the second, or the third. That's where debugging comes in. This is where your problem-solving skills will truly shine. Debugging is all about identifying and fixing errors in your code or hardware setup. It can be frustrating at times, but trust me, the feeling of finally squashing that bug is incredibly rewarding. To become a debugging pro, you need to equip yourself with the right tools and techniques. A serial monitor is your best friend for viewing messages sent from your microcontroller. A logic analyzer helps you visualize digital signals, while an oscilloscope lets you see the shape and timing of analog signals. Remember, debugging is like solving a puzzle. Break down the problem into smaller, manageable chunks. Test each part of your code or circuit systematically until you find the culprit. Chapter 5. RTOS and Communication Protocols. Leveling up. Alright, once you feel comfortable with the basics, it's time to level up your skills with some more advanced concepts. First up, Real-Time Operating Systems, or RTOS. These are specialized operating systems designed specifically for embedded systems. They're essential for managing multiple tasks and ensuring that time-critical operations happen exactly when they should. Free RTOS is an excellent open-source RTOS to start with. Then we have communication protocols, the languages that allow your embedded system to talk to other devices. You'll want to learn about UART, I2C, SPI, and CAN. These protocols are used everywhere in embedded systems, from connecting sensors to communicating with other microcontrollers. Understanding how to implement and troubleshoot these protocols will open up a whole new world of possibilities for your projects. Outgrow your embedded journey starts now. So there you have it. Those are the 5 essential skills to become an embedded engineer. Remember, The key is to start with the basics, get hands-on experience, and never be afraid to break things and then fix them. The world of embedded systems is vast and constantly evolving, so there's always something new to learn and explore. If you found this video helpful, hit that like button and subscribe for more embedded systems content. And let me know in the comments which skill you're most excited to start working on. Until next time, keep on building.